Okay. One on the left. Who can name it? How about Trevor?
2-butanol.
2-butanol. Very good. 2-butanol ends in OL because it's an alcohol. The 2 tells me where the OH is, and the but, that's the 4 carbons. So again, hopefully the next 2 nights with the homework, you guys pick this up if you're still confused. Pentanol, 1 pentanol. Sorry, who can draw this one? How many carbons? 5. Morgan, do you agree? Good. 1, 2, 3, 4, 5. Matt Payne, what's the 1 mean?
That's where something goes.
Very good.
First carbon.
Good job. What goes there? It's not a methyl or an ethyl because we're on table R now with functional groups. Now you can have methyls with the functional groups, but that's above our pay grade here.
And OH.
OH, very good. So I can put it, everyone eyes up here, I can put it here, 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 because that's the first carbon, or I can put it over here. I don't like putting it here, it just looks strange, so I'm going to put it over here. That's just usually where they put it. Even though it looks like it's on the 5th, it's really the 1st. Right? That's number 1, 2, 3, 4, 5. You're just counting backwards there. All right. So one thing I want to add about alcohols, due to OH group, alcohols, and this is nothing new. I'm just going to write one statement and move on here. Have higher boiling points, higher BP, due to hydrogen bonding. And remember, hydrogen bonding is a force, it is not a bond. So if I have one of these pentanol molecules and it comes near another pentanol molecule, the OH groups will be attracted to each other with a force. And that's going to give it a higher boiling point. Remember that. The word bonding doesn't mean bond there. It's just a strong force. So because of the OH, alcohols tend to have higher boiling points than a lot of the other ones on there. What's the other 2 elements that can be with H to do hydrogen bonding? Nitrogen and fluorine, right. NOF or UFN or however you want to remember that. Okay, so that's alcohols. Next, what is it?
Ether.
Ethers. All right, these are weird. These are weird to say. You'll see why. All right, here's a structure. Well, I was going to do the condensed. Let me do it this way. I'll use the same one I drew in the warm-up. So there's an ether. I don't think that's... No. Wait. What? Yeah, that's not the example, okay? And then diethyl ether would be the name of the other one here. So ethers are very nonpolar because they're usually pretty symmetrical. I know I keep saying that. I just want to refresh your memory. You need to remember that. Symmetrical, covalent bonding that's symmetrical usually means nonpolar. So these can dissolve things that water cannot, like paint, for example, or glue. If you want to dissolve glue, you need acetone or some sort of ether that'll work because glue is usually nonpolar. Even though some glue uses hydrogen bonding. So think about that and figure that one out and get back to me. It uses hydrogen bonding, but it's nonpolar. That doesn't make any sense. Leah, you with me? Ariel, you with me? Can you do either one of these? Name or draw?
The first one.
Use the example as your guide.
So it's.
So, okay, I guarantee almost no one knows here, so don't feel bad. Everyone go to the example. I'm going to use that to help you. if you look at the example on table R, how many carbons are to the left of the oxygen? 1. That's called methyl. How many carbons to the right? 2. That's called ethyl. So the name is methyl, ethyl, ether. Right? Isn't that what they wrote? Or did they write ethyl, methyl, ether? You can do it either way. Okay. So, there's 1 carbon on the left, that's the methyl. There's 2 on the right, that's called ethyl. So back to Ariel, how many carbons here?
1.
What do we call that? Methyl. 1 carbon on the right, what do we call that? Methyl, methyl. And that's called ether. That's the name. Methyl, methyl, ether. I feel like I'm going to spit all over the place saying that. Now, you could also call it dimethyl ether. Either one. Either one. Doesn't matter. Whatever, blows your socks off. Diethyl ether. Who can draw it?
Oh, in the middle.
Oh, in the middle.
2 carbons on each side.
There you go. Very good. There it is. There's 1 ethyl. Hello. Ethyl. And then there's another ethyl. So there's ethyl, ethyl, ether. Or diethyl ether. These are like, it's like crazy to say. All right. Anybody who has a lisp, I feel bad for them if they have to say this. So diethyl ether, that would be very challenging. So these are hard, I think. They're a little confusing, a little different. Again, can you identify it? That's the main goal here. This is kind of like bonus. If you can, draw that, you're really in a good spot. All right. I haven't seen one of these in a long time. Okay. Moving on. What's next? Aldehyde and ketone. I'm going to do both together at the same time because they're similar. Plus, I'm running out of time. Aldehyde and ketones. Okay. All right, so I'll put 4 examples up here. 2 for aldehydes, 2 for ketone, and then I don't know if we're going to get to the organic acid today, so you can have good luck with that. All right. Here we go. So they give you that one. All right, you guys give this a shot. Oh, I think this was the one I used in the warm-up. Yeah, it is. And then, okay, ketone. We'll do this one. And then we'll do 2 ketone. So again, I realize me going over these like one example for each one very quickly, you're not absorbing it, you're not really learning it completely. I get that. So hopefully the homework due tomorrow, the homework I'm going to give you due Friday will help learn these. Help you learn these. Okay, squeeze these out here before the bell. Oh, you have to skip one. Well, you don't have to skip it, but you can try it. Number 3 on the homework is an ester, which we didn't get to. We'll talk about that tomorrow in our notes. So you can give it a shot, but if you don't do it, it's not the end of the world. Number 5 is an acid. Give them all a shot, okay? But if you can't do the ones we haven't gone over, I understand. All right, real quick, let's do these. This one here on the left, I'm just going to give you the answers. This one's called ethanol. 2 carbons, aldehyde, so it ends in al, right? Al's my pal there, ethanol. And then butanol would be 1, 2, 3, 4. The 4th carbon here has the functional group. So there's butanol. Again, al means aldehyde. This must be here, 1, 2, 3, 4. Some kids forget this counts. So they'll put 4 carbons in addition to that. That's 5. You don't want 5, you want 4 total. That counts. Over here, this is called 2-propanone. 2, because that's the 2nd carbon with the ketone group. 1, 2, 3, prop, and then the one is how ketones end their names, propanone. And then 2-butanone, 1, 2, 3, 4. 2nd carbon has the double bond O, and that's 2-butanone. I know I went quick, just trying to just get as much done as we could, so good luck on the homework, and we'll finish going over this stuff tomorrow. That's it.